Hello everyone, my name's Abhishek and welcome back to my channel. In today's video, I'll talk about 15 DevOps tools that can be the future of DevOps. So basically, if someone wants to learn DevOps today, or if someone wants to become a DevOps engineer today, they know the list of tools to learn. The roadmap is clear because there are so many videos on YouTube, even on our channel. I made a detailed roadmap video. Then I made multiple courses covering those tools in detail. Now, everyone knows they have to learn Linux, Git, Docker, Kubernetes, Terraform, cloud platform. But the big question is, if someone is already a DevOps engineer and they want to continue in this space, or they want to take the next step in their career, they want to move to AI DevOps engineering role, what are the list of tools that they have to learn? That is exactly what I'm going to cover in today's video. So basically, the space of DevOps is evolving. There are new categories that are evolving, or there are new things that DevOps engineers are performing. For example, they are taking care of agent infrastructure, AI infrastructure, new tools in the space of CI/CD, new tools in the space of FinOps. So I'll talk about 8 categories, and in each category, I'll cover one or two tools that you should focus on. Overall, I'll cover 15 new tools in today's video. This is going to be very insightful. Watch the video in detail, take a note of the tools that I'm going to talk about. And if you want me to make a video on any specific tool, do let me know in the comment section. Perfect. Let's get started. So the first category, something that every DevOps engineer should focus on. This is evolving very fast. Something called agent infrastructure. Let me explain what exactly this is. So basically, every company today is building their own agents. Let's say your organization built an agent, your development team built an agent using LangChain. Maybe they built something called Kubernetes troubleshooting agent for easy understanding. Now, this agent will be used by different users within the organization. At some point, 20 users might use it. At some point, 100 users might use it. At some point, 0 users might use it. Let's say 20 users are using it at this moment. So 20 users goes to your AI assistant, or they go to your AI chatbot that you have built for this Kubernetes troubleshooting agent. They will log into the platform and they will run their prompts, or they will execute the prompts. So parallelly, the Kubernetes troubleshooting agent has to perform 20 actions. Somebody is talking about crash loop backoff, somebody is asking about pod failure, somebody is asking explain Kubernetes architecture. Now, to perform these 20 tasks in parallel, your agent would require the infrastructure. And this infrastructure should be the disposable infrastructure, or this should be ephemeral infrastructure, so that you can save the cost for your organization. As I told you, at once 20 users might ask questions to the agent. It might have to perform 20 tasks. At some point, 100 users might ask it. So parallelly, you might need 100. Agent has to perform 100 different actions, or sometime the agent might be completely idle. So this infrastructure to run the task for the agent should be ephemeral or disposable. Once the agent task is done, the infrastructure should be killed. Now, there are two tools that are evolving very fast in this space that can build agent infrastructure for you. Number one, Daytona. Number two, Docker sandboxes. Now, let me start with Daytona first. So Daytona, basically they have on-premises solution. Like, you can just go to Daytona GitHub repository. It is open source. You can download it. You can start using by bringing your own cloud, or by bringing your own on-premises. When you do that, now whenever the same concept, whenever agent requires the infrastructure, Daytona provides with the infrastructure, maybe the GPU infrastructure. And once the task is done, the GPUs are automatically killed. Now, this can be container infrastructure, this can be VM infrastructure, this can be Kubernetes infrastructure. You can configure this within Daytona. Docker sandboxes also works on the same concept, but when it comes to Docker sandboxes, I would mostly prefer this in the developer environment, because just like how you use Docker containers within your developer environment, when you go to production, you use Kubernetes or you use an orchestration layer. I would use Docker sandboxes in the same way. But these are two significant platforms. I would highly recommend Daytona. Like, if you even want to learn about one tool out of this 15 tools, Daytona is something that I would recommend, because agent infrastructure is evolving very fast. Every company needs this in the future. And as a DevOps engineer, you can take up this responsibility. Perfect. So this is the first category. These are two different tools. Then the next category, developer sandboxes. Now, this is there for a while. Let me explain what exactly is developer sandboxes. Now, within your organization, let's say a new developer joins the team. Now, you would your organization would provide them with a laptop, but within this laptop, they have to configure a lot of things. Like, for example, they have to install the required tools. Maybe they have to run the databases locally, they have to install Python, JavaScript, their application, set of tools, and most importantly, they have to make sure the right versions of these tools are installed. Otherwise, there is no use. They run the application locally, but it wouldn't work. Now, this problem, like, this is a lot of effort. Every time there is a new developer, you have to provide them with a machine, they have to configure, they have to run the right versions on it. This can be eliminated using cloud developer environments. As I told you, cloud developer environments are not very new. GitHub has their cloud developer environments. There are a lot of companies that provide CDEs. This is traditionally taken care by DevOps or platform engineers. Now the thing is that CDs are evolving a lot. Today, companies have two primary actors. Understand this carefully. Now, traditional CDs, they work for developers, like a cloud developer environment. A platform engineer would provide them with a Linux virtual machine that is pre-configured with all the packages, all the right versions. Now, the second actor within the organizations are the AI agents. Today, some companies are also using multiple agents within their organization. So the CDE platforms that you're using should also support the agents. One such platform that I would recommend is the Coder platform. I made a very detailed video on Coder. I explained how to install Coder, how to configure it for cloud developer environments for both the developers as well as the agents. If you are interested, you can watch the detailed video on Coder. So this is a second category. What problem it is solving? Once again, you don't have to provide your developers with the laptops. You don't have to provide them with the steps to configure, install packages, versions. Instead, you can provide them with a sandbox, or you can provide them with a workspace that is equipped with all the things. That is called as CDs, cloud developer environments. Now, within the cloud developer environments, previously there was only one actor like developers, but now there is another actor called agents. Platforms like Coder, they support both the agents as well as the developers. If agent is requesting for a workspace, Coder can provide the agent with the workspace. If developer is requesting for the workspace, Coder can provide relevant workspace for the developer. And these are long running workspaces. So this is the second category. Now the third category, something that many of you are already aware of, infrastructure as code. Now, Abhishek, for infrastructure as code, we use Terraform. Terraform is the best infrastructure as platform tool even today. But if you want to explore more on top of Terraform, you can explore platforms like Spacelift. I'll tell you what is the advantage. Now, Spacelift wouldn't do anything new for you, but it provides the orchestration, or it makes the orchestration easy for you. Let's say you're using Terraform within your organization and you're also using Ansible within the organization. Using the Spacelift platform, which is free for the majority of the use cases, you can integrate Terraform with Ansible. For example, if your requirement is to create an EC2 instance and then to install application, packages, firewall within the EC2 instance, You can use Spacelift. You can use your existing Terraform files. You can use your existing Ansible automation platform. But within the platform, using just simple add-ons or simple plugins, you can integrate your Terraform code with Ansible code. So you don't have to write a new SDK. You don't have to create an orchestration layer. Just use the Spacelift as a platform. Perfect. So if you're dealing with infrastructure as code, this is one platform that I would highly recommend. But Abhishek, we are not using Terraform itself. We are in the space of Pulumi. Now within Pulumi, there is one thing called Pulumi Neo. The best part about Pulumi Neo is that you can just provide a simple natural language prompt. So as DevOps engineer, you would install Pulumi Neo. You would tell your developers or you would tell your QA team, just provide a natural language prompt. This will write the entire Pulumi code. And this Pulumi code is also deployed and infrastructure is automatically created. So if you are in the world of Terraform, try to look for Spacelift, upskill yourself. If you are in the world of Pulumi, try to look at Pulumi Neo and make the infrastructure creation or infrastructure as code much easy for your organization. Now the fourth one, Kubernetes troubleshooting. Now, why Kubernetes troubleshooting? Okay, today Kubernetes is very widely used by DevOps engineers, but if you look at the Kubernetes landscape, this is used beyond DevOps engineers. For example, Kubernetes has become an operating system layer for running your agents as well. Just like how people run applications on Linux, today companies are running their AI workloads on Kubernetes. They are running their ML workloads on Kubernetes. So almost every company is using Kubernetes. In this case, the troubleshooting of Kubernetes becomes a very important task. Now, as a DevOps engineer, you know Kubernetes troubleshooting. I totally agree with it. But imagine hundreds of troubleshooting requests. Why would you do that? Or how would you manage your time troubleshooting hundreds of Kubernetes issues? Majority of those issues might be trivial issues. Crash loop backoff, image pullback, image error pull. Now, if you keep troubleshooting all those issues one by one, you will spend majority of your day on it. Instead, just install tools like K8GPT. Huh? It's not mandatory, but when you have tools like K8GPT, you can tell your developers, I have installed K8GPT on the platform. If there is any issue, K8GPT will send you a notification, right? You can configure it in a way. Whenever developer runs into a crash loop backoff, K8GPT automatically troubleshoots the issue and sends a notification via email or maybe a Slack notification. This way, you can significantly reduce your time on troubleshooting Kubernetes issues. So this is a fourth category. Now, previously this was optional, like it's okay if you install it or not. But looking at the usage of Kubernetes, tools like this are becoming mandatory. The fifth category, CI/CD. Now, one of my favorite categories because even when I deliver freelancing projects, I make sure whether clients ask for it or not ask for it, I would set up the CI/CD pipelines for them because it increases their production, the ease of going to production, or it increases their release efficiency as well. So I make sure CI/CD is set up. Now there are very good CI/CD tools when it comes to DevOps. For example, GitHub Actions, a very easy tool. If your application is already in Git, like your source code is already in Git, you can just write YAML manifest and you are good to go. The CI/CD is set up, but there is one challenge with it. Now these YAML manifests, of course, GitHub Action supports modularity. Of course, it supports packaging. But the problem is that you are writing end of the day this in the YAML format. Instead, if you can code this entire thing, if you can write your CI/CD as code, then it becomes much easier for packaging. It becomes much easier for modularity. And most importantly, instead of writing thousands of YAML files, right? Or instead of writing hundreds of lines of YAML files, you can just write simple YAML file and you can execute the code within the YAML file. I'll make it easy for you. There is a platform called Dagger. I would highly recommend you to go through it. What Dagger does, now within your GitHub Actions, you write multiple steps. For example, step 1, clone the application or clone the source code. Step 2, build the application. Step 3, package the application, run unit test cases. Step 4, deploy the application. Let's say these are 4 different steps. For this, you will write the YAML file and you will use multiple actions within GitHub. So maybe your YAML file becomes 100 lines YAML file. Now, if you go with Dagger, you can code this entire thing in Python. Now, Dagger has something called Dagger SDK. It supports GitHub Actions, it supports GitLab pipelines, it supports most of the CI systems today. Now, because it supports most of the CI systems, using Dagger SDK, using Python or TypeScript, you can write this entire thing as a code. Now, what happens when you write this entire thing as code? The code that you write can be executed as one of the steps in the YAML file. Now, what will be the structure of your YAML file? Basic metadata of your YAML, then basic clone or downloading the source code, then execute the Dagger CLI. That's it. From 5 steps, you brought it down to 3 steps. When you execute the Dagger CLI automatically builds your application, packages your application, deploys the application. I know for the first time, you might find it tricky. You might find it difficult to understand. But when you look at a Hello World Dagger application or when you move your first application to Dagger, you will realize how simple it is. Then the 6th category, DevOps agents or AI DevOps agents. Now there are different AI DevOps agents. For example, AWS launched their AI DevOps agent, Azure launched their DevOps agent, Google Cloud Platform launched their DevOps agent. But instead of depending on the cloud platform, I would recommend go with a vendor neutral DevOps agent, something like Kubia. Now you can search for Kubia. I made a video on Kubia as well. Basically, this is a DevOps agent that you can integrate within your Slack. So your organization has Slack. Within Slack, you can configure Kubia. What this does, when your developers have questions related to DevOps, it can easily answer the DevOps questions. Or your developer has questions related to your infrastructure. Kubia can answer that within the Slack. Or someone wants to create an S3 bucket. They can just call Kubia and they can say, Kubia create an S3 bucket. It would create an S3 bucket. Or they can say, Kubia create an EC2 instance. It can create an EC2 instance. And what it can do, you can configure as an admin of Kubia. Very simple. Step 1, install Kubia on your Slack. Step 2, configure what set of actions that it can perform. Let's say anybody can create an EC2 instance within your organization. You can tell Kubia, when someone requests for an EC2 instance creation, just go ahead and do it. Do it within the VPC, do it within a particular region on the cloud platform, and it will do that action. Especially if you are a small DevOps team, I would recommend you to configure something like this so that instead of getting 1,000 requests, you can bring that down to 100 requests, right? Trivial task can be done by the Kubia agent. Best part, this is vendor neutral. This works with AWS, this works with Azure, this works with GCP as well. Now the 7th category, my favorite, AI SRE. What is AI SRE? So when you look at SRE engineering, there are so many things that you do as SRE engineers. And most of these things are production critical things. For example, site goes down at 2 a.m. in the night, or there is an incident that is reported on your production system. Now, you can perform your troubleshooting as an SRE engineer, but still there are so many things to do. For example, you have to create a Slack channel. You have to add the right people to the Slack channel. Then you have to create a root cause analysis document. Then you have to follow up setups meetings so that everyone understands it. Then you have to perform multiple discussions on the RCA document. You have to make sure next time something like this is not happens, or you have to make sure Jira tickets are created and you track so that in future you don't repeat such issues or your organization don't run into such issues. This is so much activity. Now, this can be automated if you go with AI SRE platforms, something like Resolve AI, or you can go with platforms like Incident.io. And these are the two platforms that I would recommend. Of course, if you're using PagerDuty, you can integrate Incident.io or Resolve.ai along with PagerDuty. Now, this thing doesn't have to change. Your PagerDuty can remain the same. But make sure you go with platforms like Resolve.ai or Incident.io. Finally, the last category, cost optimization. So, why cost optimization? This is a very critical responsibility of DevOps engineers. Lot of people unfortunately ignore this, but you can save a lot of money for your organization by setting up strict compliance, by setting up a cost optimization by identifying stale resources, especially how expensive are GPUs. Today, if you look at Kubernetes clusters that are running on GPUs, if you can save maybe couple of nodes on your Kubernetes cluster, or if you can reduce couple of nodes, you can save a lot of cost for your organization. Because most of the times, developers would request for Kubernetes clusters, but the Kubernetes cluster usage would only remain at 20 to 30%. But you're still paying for the rest of the 70% on the cloud platform. Cost optimization was very important in the world of CPUs. Now, in the world of GPUs, that has become even more important. Two tools that I would recommend. Now, the first one is Cached AI. Cached AI works very well with Kubernetes. So if your organization is in the Kubernetes infrastructure, the best part, they are free to get started with. They won't charge you. Let's say if your organization has Kubernetes clusters, only if you save money on the Kubernetes clusters, they would charge you on the money that you have saved. Understand this carefully. By default, they won't charge you. Let's say if you saved 100K US dollars on the money that you have saved, they would charge you. So just connect Cached AI with your Kubernetes clusters. See the list of steps that it tells you. Okay, this is where you can save, this is where you can save, or this is how you can configure your Kubernetes cluster so that it becomes least expensive. Maybe if you're not in the Kubernetes ecosystem, you can go with something like OpenCost. Right? With OpenCost, you can configure not only Kubernetes, but you can also configure different infrastructure and see where you can exactly save the money. Perfect. So these are the list of tools. Of course, you can go with KubeCost as well, but I would recommend Cached AI. So these are 8 different categories, right? Once again, just go through the video, note down the list of tools that I was talking about. Make sure you have those lists in your learning list. Trust me, this can help you big time if you want to continue in the space of DevOps, or if you want to move to the next level, such as AI DevOps engineer or any other transition related to DevOps. If you still have any questions, do let me know in the comment section. I'm more than happy to help. See you all in the next video. Take care.